Hi everybody, this is Sarah Al-Amiri in Why Not Show.
Hello everyone and welcome to our program Why Not? I'm your host Ahmed Murad.
Lovely viewers of Why Not? I am your host Rita Jishkinani. Hello dear viewers, I'm your host Rita Jishkinani and you're watching Why Not? Today's episode starts with a simple question. Why not experience science in a different way? Why not take learning in a fun and educational way? And that's exactly what we're gonna do in this center, starting from here all the way into space. Here, as you can see, we are right in the center. And as we move backwards, you can see Kuwait, our beautiful, beautiful Kuwait. And the more we move further away, we enter space. Over here, this space takes us somewhere very familiar. As you can see, do you recognize anything over here? This is our beautiful Kuwait. It shows us all the natural areas in Kuwait, all the islands, all the reserves. Let's see. I already recognize some towers, some of our malls. I wonder if I can see my house from here. Let's see. I already recognize the city. Look over there, a table. Let me see what it has. So it's illuminating light from below and it's filled with sand. Let's see if I can write something. And let's see if you guys can guess what I'm writing. Do you have an idea already? Let's keep going. How do you guys think I did? Why not? Now, let's see what else this space has to offer. As I said, it takes us somewhere familiar and teaches us about the Earth all the way to space. Let's see what this is about. As you can see, it's a bowl filled with water and it's called the Confused Sea. And it's telling us to turn the knob. Let's see what's gonna happen when I'm turning the knob. The wind speed in the tank. It changes the wind speed in the tank. And watch how the waves change. So as you guys can see, as I'm turning the knob, the faster the water is moving and waving. Let's see. And that's why it's called Confused Sea, because I'm confusing it. It's going every direction. Can you make a small water spout that sprays up into the air? Let's see if I can achieve that. The more I turn it, let's see if I can make it splash around. Let's see. The waves you see at a beach are created by wind moving over the water. Similar to what's happening right here. Waves can grow large when they are pushed by particularly strong wind or when they are pushed for many kilometers. Okay then, interesting. Well, I think that's enough of this. How about we go check something else out? Over here, we have so much more waves. Let's check it out. We have a bunch of buttons. Let's see what they do. Here we have the wave size, as you can see. And we can play with the steep beach and shallow beach. So, use the dial to make the waves bigger or smaller. How does their size affect how they break? Let's see. So, wave size. I think right now, as I'm turning it to the left, I'm slowing it down and making it, how do I explain this, wider? Slower? Let's see if I turn it to the right, what happens to the waves. I think the waves are becoming so much shorter and faster. Let's see the steepness of the beach, what happens to it. Okay then, so now it's lifting what's supposed to be the beach. And it's stopping the water. Let's see how, and making it shallow. What's the difference right here? Okay then, now let's read a little bit about it. So as the wave approaches the beach, it collides with the shore. And it slows down, exactly what we saw there. Like a roller skate, traveling from a smooth floor into carpets. The bottom of the wave slows more from the top. The bottom of the wave slows more than the top, causing the wave to pitch forward and break. The slope of the beach and the size of the wave determines its shape. Well, the more you know. Let's see what else this center has to offer. Guys, look how gorgeous this is, the moon right in front of us. How about we read something about it? The moon rotates in such a way that the same side always faces the earth. And I always wondered why does the moon always look the same? Actually, I've always wondered, or maybe it's just me, but the moon always looks like it's smiling to me. Now let's see what they have here over on this side. We have fossils. Do you guys know anything about fossils? So in front of me right here is several kinds of cephalopods. I hope I'm pronouncing that right. And I guess their remains died and fossilized, which means their remains became hardened, as you guys can see. And I think I recognize two types. I'm pretty sure this comes from, if you can see, this pointy fossil over here comes from a sort of octopus or from the squid family. And look over here. I'm not too sure what I'm looking at over here, but it looks spiky and pointy. How about we read something about it as well? So these actually come from the same family of insects, crabs. It's very interesting and it's so tiny. I love it. I might look a little crazy right now twirling this table, but I'm trying to see something. It's a swirling storm table. So what it's telling me to do is turn the table slower or faster and in both directions. And it's supposed to create, as you can see, some sort of storm. Let's keep twirling them around. I'm twirling it to my right. And let's see what's happening. You can see that it's going into what's supposed to be the storm's hole where it begins. Let's read what it says. Swirling storms are called tropical cyclones. They form over patches of warm water at the sea. The warm water heats the air, causing it to rise. So I think that's what's happening right now, if you can see. And it seems like it's like pushing the water away as well. Air rushes in as wind into space, left by a rising air. But the force of the Earth's rotation pushes the wind off course. As you can see right here, you can see that the wind is getting pushing the water away. And the wind begins to circle the rising air, creating a swirling cyclone. I've always wondered how storms were created, so the more I learn, the more I know. Let's see what's over there. I see some smoke. Let's see what it's all about. Over here we have turbulent air. As you can see, there's a bunch of fog. Let's see what it's all about. So closely observe the fog. What patterns do you notice? It looks like waves to me. Very, very messy waves. Maybe there's no pattern in my eyes actually. Do you guys see anything? Well, wave your hand through a patch of fog. What happens when you disturb the fog? So let's see what happens. There's a lot of fog here. Let's see what happens when I wave my hand. It backs away, or it follows me. It's doing everything actually. It's very messy. Well, let's see what the reasoning behind this is. So what's going on? The movement of the air is made by visible water droplets in fog, allowing you to see the swirling patterns, which is exactly what I'm seeing. They look like waves that form when the airflow is disturbed. This chaotic pattern, as I said earlier, it just looks like a mess. It's called turbulence. How cool is that? I think that's a fun name, and it describes exactly what I'm looking at. Water is fluid like air and moves in turbulent patterns. Well, that's an interesting fact. Did you guys know about that? How about we venture into the vast universe of our planet? Let's see what this is about. Satellite Orbit Simulator. As you guys can see on the screen, I'm going to be playing as the yellow satellite. We have two buttons right here, a relaunch button and a speed button. So, use the joystick to make a satellite move faster and slower. So let's see what happens. Again, I'm the yellow one, and let's see what happens when I move slower. Oh, I think I just crashed into Earth. Let's try that again. Relaunch and see. So when a satellite moves at just the right speed, gravity holds it in a repeating loop around the planet called an orbit. So I'm trying to do that, but I'm doing a really bad job. If the satellite moves too slowly, gravity will pull it onto the planet, and that's exactly what I've been doing. I kept on going too slow and I kept crashing into the Earth. Well, the more you know. Let's see. Dear viewers, do you see this big screen behind me? Can you recognize what it is? Let's see what it has to say. So over here, it's actually the sun, and it teaches us about the different layers of the sun. So let's start off with the main layer, which is the core of the sun, and it's actually called the corona flaring regions. Let's see what it has to say. So first off is the main core of the sun. It's called the flaring region. As you can see all the blue. I did not know the sun is blue from the core. Now the next layer, which is also called corona, is the active region. It's the outer layer of the sun, which is hotter than layers close to the core. Now the third layer, let's see what it's called. Upper chromosphere. And if you can see, there's like jets of plasma coming out, and they're actually called spicules. And then this is actually us as humans, what we can see. from Earth to the sun, this is what we see. Red, yellow. Now this is called the lower chromosphere. And this is something much deeper that scientists can see using their huge telescope, something that we don't have. Now let's see what else this center has to offer. We have some apples. Let's see what it's all about. As you guys can see, we have 2 apples, one as a whole and another cut in half that was added this week. We have another as well added 1 week ago, another added 2 weeks ago, another added 3 weeks ago, and 4 weeks ago. And as you guys saw, the more the weeks go by, the more spoiled it looked. And this is because of something called decomposition, which means breaking down. And here we have bacteria and different fungi breaking down the dead organisms on the apple. Let's see. And as time passes by, due to the humidity, the weather in general, the rate of decomposition changes. So maybe the more humid it is, the faster it goes. Well, that's an interesting fact for today. Dear viewers, we are now on the 2nd floor, the engineering world. You know, our engineers, they always come up with solutions and different processes for us. Let's see what this table here is. As you guys can see, we have a table here with a disc that's spinning and a bunch of bits and bobs. And I think what we have to do is experiment by placing one. Let's see what happens when we put this on. And it's off the table. Let's see one more. Let's try with this ball right here. What happens when I put it on the spinning disc? Oh, that was really loud. And it's staying. This was a success. Let's hope it doesn't go off. And basically what I think is happening is, you see, from the inner disc, it moves much slower than the outer disc. That's why you saw that one bit and bob just fly off. How cool is that? Well, we are here at the animation station. Basically, the team and I already designed something, as you can see. Why not? And with our little friends, the robots. And what we have to do here is take pictures of each step to create our own little movie. Let's see what we come up with. Let's play animation, if you can see. We have our own little why not intro. Maybe we can use it for our future episodes. over here is the shake table, and the main idea is creating a building or any object of your choice and see if it can withstand an earthquake. So let's see if I build a house, can it survive an earthquake? Right here we have a bunch of bits and bobs. So we have these small pipes. Let's create something. We also have some rubber pieces. I don't know how to use them, but let's add them to my little house. Yeah. And let's end it off with this base on the top. Here we also have another building made by one of our members. So let's see whose house can withstand an earthquake. If you guys follow me on this side, we have all the buttons right here. So we're on build mode right now. Let's turn it to test. We have different types of earthquakes. We have a small earthquake, but that's far away, a small earthquake that's nearby, large earthquake that's far away, and a large earthquake that's nearby. Let's see if it can withstand a small earthquake that's far away. We have two of our buildings right now. Oh, okay, mine already fell, but never mind. I was gonna say this one was holding up very well, but I guess not. We need a little practice on our little building. Dear viewers, look what I found. If you see right here, we have this huge pendulum. And if you noticed, it's swinging. And it swings at its own frequency called a resonant frequency. Now what it's asking us to do is to swing this string that has a magnet attached to it. So using this, I have to swing and get it attached to the pendulum. Let's see what happens. Whoop, nope. Let's do it again. There we go. Now, all this is about is the push and pull and how much we can push and pull the pendulum. So if you see, if I pull at the right time, I can make the pendulum move a little faster, even if it's a little pull. But if you see me pulling it maybe at the wrong time, like right now, it doesn't do much. It's all about timing. So now we are at the solar workbench. Let's see what they have. Here we have a fan. But to work the fan, we're going to need something like a solar panel right here. Now if we lift it up, you can see that the fan is also working. And for the solar panel to work, we also have a light source that's supposed to play as the sun, right? Now over here, I have three sort of, let's say, tints. Okay, I like to think of it as a car tint. Let's say this is 100% car tint. We can say maybe this one is 70%. And let's say this is 30%. Now what it's supposed to teach us right here, okay, if I get up, okay, is what happens to the fan and its power meter depending on the types of shade that we use. So let's start off with the 100%. When I place it on top of the solar system, blocking the sunlight from the solar panel, you can see that, well, practically the fan stopped working because it's stopping all the power from entering the solar panel. Now let's see the 70% one right here and what happens to the power meter, as well as stopping the whole fan from working. Now the 30% stops the solar panel and the fan completely. But let's take it off because honestly, I'm enjoying the cool wind. So over here, you create your own parachute, but I don't want to create one. I just want to see how this flies in this wind tube. Whoa, look at that. Let's see if it can have a soft landing. Let me see. So we're gonna try to make our own airplane right here. So I have a piece of paper. Let's see if I can make something. It's been a while since I've created anything using paper. Okay. This is not the traditional way of making an airplane, but this is how I make airplanes. So let's see my aircraft right here. I think it's pretty good, has a good feel to it. Now we have to place it into this thing right here called the plane launcher. And what it's supposed to do, if you look carefully, there's two spinning wheels inside. And it's supposed to grip the plane and launch it. Now let's see if I can get it through the hoop and maybe hit the target over there. Let's go. But first, let me aim it. Oops. Oh, using this rotation right here. And off we go. Let's do that one more time. Okay. Let's see. Oh, no, I didn't even go past 100. Well, it is a try. Why not? Here I have a beach ball, but we're not at the beach. We're gonna try something really cool called the Bernoulli blower. If you see this cone right here, it's pushing out really fast air, low pressure. Now what happens when we place the ball above it? Let me just lower the... And it slides right up and it's standing in place. The air around it is surrounded by high pressure. Even when it moves out, it's gonna push it back in place. Now, how cool is that? Well, dear viewers, That's all we have for today's episode, and I hope you had so much fun as much as I did, learning so many new things about this world. Until next time, dear viewers, you're watching Why Not? Bye-bye.
Hi, everybody. This is Sarah Al-Amiri in Why Not Show.
Hello, everyone, and welcome to our program, Why Not? I'm your host, Ahmed Murad.
Lovely viewers of Why Not? I am your host, Rita Jishtirani.